Alright, good morning. Welcome back to DS Radio Shop. So, hot topic this morning, potentiometers and trimmers. What are they all about? Well, quite simple really, and let me pull a couple of examples too, because it seems to be people that are really confused and should not be working on radios if you don't know what the component is. That's very scary, because you could damage a radio by putting the wrong component in. So, let me grab a couple things here. I'll grab a couple of parts radios to show you. Because some people actually did a video. This guy did a video. It's very embarrassing. It really is. He did a video 3 days ago on a Connex 3300 ZX. Had multiple bad solder joints, and apparently he pulled out these trimmers from the radio that were in the bias section, and they don't use trimmers in bias sections. They use potentiometers. Okay, he calls a trimmer. He literally said this is a trimmer that somebody put in, but if you take one lead away, it becomes a variable resistor. That is not true. So, you cannot confuse a trimmer versus a potentiometer. When you put those into radios, you got to understand your componentry. This is what they call component recognition. Okay, it's something you should learn before entering a radio and just playing with components because you think you know what you're talking about. So, there's several different, I guess you want to call them appearances, if you will, as to how these are built and designed. So, for example, let's start with just a few things right here, okay? Okay, these are all trimmers, okay? A trimmer is a variable capacitor. So you've got fixed capacitors, which are electrolytics. You've got ceramics. You've got mylar. There's all kinds of variations of capacitors, right? As the same for resistors. However, a trimmer is a variable capacitor, which means you can change the variation of the value of that capacitor. So, for example, let's say we have a, 1 picofarad cap, but we need it to be a little variation in between. Maybe it's got to be 1.8 or 0.7 or something like that. Then you would find a trimmer cap that will give you the variation you can adjust to pull that in to get your value of the capacitance you're looking for. That's what these are for. So these are variable capacitors. Now people look at this and say, well, that's just a coil. No, that is a variable capacitor as well, because if you look on the inside, it has a capacitor right here. That tubular piece is a capacitor. Okay? So this is a variable trimmer, a variable capacitor, right? These are all variable capacitors. These are all trimmers. Now let's slide over to this here. These are potentiometers, not trimmers. These are variable resistors. You can change the resistor value with these. You can vary the value. So the guy had a variable resistor he called trimmer, which was completely wrong. Doesn't even know what the hell he took out of the radio. And then he said, if you take one of these leads away, now it becomes a variable resistor. That is false information. A variable resistor is exactly what you see right here. Whether I take 1 lead away, 2 lead away, 3 lead away, that component is still going to be a variable resistor. So if I had a car in my driveway and I took the body off the whole frame, it's still a car. Okay? If I took 4 wheels off and let it just sit there on blocks, it's still a car. If I remove the engine and half the other stuff with it and I got 50% of it left, it's still a car. Well, or what's left of it, right? So this is a variable resistor, not a trimmer. Whether I take 1 lead off, 2 lead off, 3 lead off, it doesn't matter. whether I did it intentionally or someone else did it, and they want to break a leg off for whatever reason. Maybe you only need one lead, you don't need three inside of a circuit. That's fine. It's still a variable resistor. These are all variable resistors. Okay, these are not trimmers. These are variable resistors. Now, I'm going to point something else out. This is where he got confused. Let me get my deal here. This right here, again, and it says it right on the package, potentiometer. That's what it says, potentiometer, guys. Now, what does that mean? Well, again, variable resistor. Well, how do you know? Because it says right here, 100 ohm, that's resistance, 1K for 1 kilo, resistance, 10K, so forth, okay? These are not trimmers. These are variable resistors. These are potentiometers. That's the little pot on top you would adjust. Whether I take one lead off or not, it's still a potentiometer. That's what these are, okay? These are not trimmers. He took one of these out of a circuit and called it a trimmer. If you are a technician and you don't know your components, you are not a technician then. Clearly, you are not a technician, because the first thing you have to learn is component recognition. That's understanding the physical aspects and identifying what the component is. That's the first thing you got to do. What is this component laying in front of you? You have to identify that component. If you cannot identify the component as its correct terminology and characteristics, you have no business being inside of a radio. So, the hot topic today is potentiometers versus trimmers. What's the difference? What do they do? What are the functions? Because, again, this was brought to mind. I had several emails I woke up to this morning. I was like, are you kidding me? I said, you guys, oh my God. I said, all right, well, this makes a good hot topic, because it's very easy to misconstrue what a component is by looking at it if you're not sure. And if you're not sure, then you're not a tech, okay? Because the technician, in order to become a technician, the first thing you got to do is identify the part so you understand what you're looking at, what the functions are, and why did it go bad, or why are you testing it to see if it's bad or not. If you don't know what you're testing, and you're testing a diode and you call that a transistor, for example, well, then something's wrong. Because you clearly don't know what you're doing, you don't know what section of radio you're in, you don't even know what the hell you're testing it for. You're just touching stuff and calling it what you want because you want to sound smart with big fancy words. Can't do that. Component recognition. Recognizing the component, identifying the component, understanding the component, its functions and features, and what it will do in a circuit. That is all component recognition, okay? So if you cannot understand that, you should not be inside of a radio. Good morning, Brent, Matt, Rick, Alan, Kevin, Federico, and Mr. Richard UK. How are you guys? Oh, Leadfoot's fine, yeah. He's probably just sleeping or sandbagging. He was out late last night on the Zello there. He's doing okay. Yep. So, again, this is all potentiometers, okay? So the reason of this video is because this guy in New Hampshire, everybody knows who we're talking about, again, produces more videos of things he has no idea what he's talking about. And the solder joints in which he had found, ironically, it's funny, hello Ryan, is because where he was touching the solder joint had nothing to do with the reason why the radio was cutting out transmit receive. Had nothing to do with it. So I sat there scratching my head watching the video thinking, oh my God, this is like embarrassing, really embarrassing and humiliating to himself, not to mention all techs across the world. It makes everybody look stupid because of what he just did. So I wanted to point this out as to what these things are. Okay, now you understand a little bit as to these are potentiometers, the different size, shape, and characteristics as far as how they look. Okay, these are potentiometers right here. All variable resistors. Okay, they change the value of resistance. These are trimmers. These are different shapes of trimmers. Okay, that's a trimmer because it has a capacitor on the bottom of it. So this is a trimmer. This is a variable capacitor known as also, like, these are trimmers. You consider that, which is basically a variable capacitor. So a trimmer is a variable capacitor. This is also a variable capacitor because it has the variation of a capacitor inside here. So as you tune that trimmer screw, it changes the capacitance in which was inside this can. Everybody understand that now? So if you're watching videos like the numbnut in New Hampshire that still doesn't understand what he's doing, please guys, don't send your radios to hack shops. Don't do that. You're gonna get yourself, all messed up and upset, and you're gonna get charged money for people who put these fake Watson radios and don't know what the hell he's even touching or changing, and don't be a part of that. Don't be a victim, guys. Send your radios here or to someone you know and trust. Don't send it to someone who has no idea what the hell he's doing. Now, let's move on to find out what exactly do these things look like and why. Well, we just discussed the component recognition, right? Right here is a potentiometer. That is a potentiometer. This is a bias right here to the driver stage. This is an old 148. This is a potentiometer right here, which is adjusting the variable resistance to the bias stage, not a trimmer. Okay? Here's another unit. This little guy right down here. See that guy right here? And this is actually perfect because these are side by side. I like that. So, you guys see this guy right here? That's a trimmer. Okay? This is another formation of a trimmer. He's a variable capacitor. There's a diode, which is made up of capacitance, but it's not variation. This is a variable capacitor. That's a trimmer. This is a potentiometer. Variable resistor, variable capacitor. Potentiometer, trimmer. Say it with me, guys. Potentiometer is variable resistance. Trimmer is variable capacitance. Everybody understand that? So if we go back here, and you see this guy right here, that is a variable resistor, which obviously this is a parts radio, so that one's missing. But this would have gone to the final stage. That goes to the driver stage. Okay? And so it's very important that you understand, like here's another symbol right down here. Come on, get the wire out of the way. Okay. See that symbol? My light turn, I can't. Here, it's another variable resistor. So variable resistor, variable resistor, variable resistor, variable resistor. So all potentiometers, where they would be. These three are missing, but they would look like this guy right here. That's your potentiometer. Okay, that is a potentiometer, variable resistance. Okay, guys, so everybody understands. And we just showed you what the trimmers are. So there's variable capacitance under these cans. Not all, but most of them. And then here's your trimmer cap down here. Okay, that's your trimmer cap. So potentiometer, variable resistor, trimmer cap. That's why they call it cap for capacitor, variable capacitor. So if you pull a trimmer out of a bias section, then something's wrong. It shouldn't have been in there to begin with, and it would have blown the finals. You cannot do that. Okay? Now, here's another formation. That is a variable resistor. Variable resistor. Variable resistor. Okay, these are all potentiometers, guys. They all vary resistance, not capacitance. These change value in which what they are holding capacitance, or just maybe they could be just coil cans, tuning cans. But a lot of these will have capacitors into them, and a lot of them will not. Okay, this down here, see that? This guy right here, VC2, that is a trimmer pot, which is a variable capacitor. Okay, so let me that right here is a trimmer pot, variable capacitor. Okay, so there's your variable capacitor, a trimmer, and then these other guys right here are variable resistance, potentiometers. Don't get them confused, guys. If you're pulling out trimmers from a radio and where it belongs with one of these, then that radio is not going to function. It's going to damage your radio, potentially damage your radio. So, and if you were to pull, a trimmer out like this, which only has 2 leads anyway, but let's just assume that it had 3 leads, which would not, but let's just assume that it did. Then whether you take 1 lead away or not, it's still going to be that trimmer. Okay, most trimmers do not come with 3 leads, only 2. Now, if they do come with more, it's because you've got tuning cans, such as these guys here, that changes the capacitance value of that crystal, okay, to pull in the frequency. So a lot of these, which 2 are missing, whether that be your AM upper lower sideband, these all 3 do have that little capacitor, little tubular capacitor I showed you on the other one, in the silver can. These all have the capacitors in the bottom of these cases. And these allow you to tune the capacitance to change to get this oscillating crystal where it belongs on frequency. So this is very important to understand, that this is a tunable capacitor to help get this into frequency. Okay, so this is going to have five points on the bottom plus 2 grounds. You're not, in most cases you might see like most of those all grounded out, but 1 or 2. But these have multiple pins. There's 5 pins, 2 on the input, 3 on the output. Okay, that is a variable capacitor in this tuning can. Okay, these are variable resistors, potentiometers. Everybody understanding the reason why we're kind of repeating this over and again, so you understand and identify the part, understand the part, and realize what the characteristics are for these componentry. This is to change oscillation, frequency, time. Okay, capacitance value is going to change all of that to get these crystals and circuitry in line when you do an alignment. These are also part of an alignment, but they change variable resistance characteristics, not capacitance. These change variable capacitance, these change variable resistance. Okay, everybody got that? Does everybody understand? Does anybody got any questions? Go ahead and ask, and I'll tell you right now. So that exactly, Matt, which is why they're located as VR, variable resistor. Thank you, Matt. Very good. Yep. When I'm live, you can't. Why are you not doing it live? What? What?
Yes, it does. It says credits. It shows credits. It's Will Smith, Kevin Hart, Dwayne Johnson.
So what about it?
It says credits, and that's the names of it.
Of what?
Our TV.
So our TV is called Will Smith and Kevin Hart.
That's what the credits are saying.
No. It's an LG or it's a Philips or it's a Samsung or I'm live stream. Don't bother me with that stuff right now. Close the door. I don't care about Kevin Hart and Will Smith. Goodness gracious. You don't bother me when I'm live stream. Anyways, guys, she's so worried about the name of a TV. I guess Kevin Hart and Will Smith call TVs their own names now. I don't know. I don't care. So now you guys understand the difference of what you have here as to what these are called. Now, Matt brought out a very good point, and I should have done that, and I didn't. I was basically talking about everything else here. So thank you, Matt, for saying so, because I want to point this out. Matt was mentioning about VRs. Okay. Well, if you guys look at this, it says VC2, right? What does that mean? VC, variable capacitor. And how Matt mentioned about VR. When these things like VR, like VR8, see how it says VR? That's variable resistor. R for resistor, C for capacitor. Variable capacitance, variable resistance. So thank you, Matt, for bringing that out. Very good point. Excellent. Glad you're paying attention. And that is actually very important to understand as well, what the board the board identification is, because I wasn't even thinking about that at the moment. I was more concerned about everything else with the characteristics of the component, but to ID it on the board is to know what the part looks like, but also the writing of that as well. So, let me bye. See you later. So now you guys know all of that, okay? If anybody has any questions, go ahead and ask, or put your comments down below. But please do understand, when you have people tell you he pulled out a trimmer from the bias section, then stop right there, because he clearly does not know what he's talking about. What he's doing is he's watching everybody else's YouTube, and he's just pulling out parts that people say, yeah, this is bad right here, and that's bad right there, and whoever he watched the video, or whoever's telling him this, told him to put down the wrong component, because that's not the component in which he had taken out. What he took out was a variable resistor, a different style, which is like what I showed you, the Bojack kit, and that was the blue casing, which is a variable resistor, whether it be on the side, the top, wherever the adjustment is, it's a variable resistor. It's not a trimmer.
What happened now?
Yep, TR is transistor or Q, and then D is diode, C is capacitor, and so on. Yep, very good. Yeah, you guys are paying attention. Very good. Yeah. So now you guys know what what these parts are, etc. Because otherwise, a lot of people don't realize what they are getting into, and they start changing things out. So if you have a trimmer here in place of these biases, your radio is not going to work. In fact, it's probably going to damage or fry those finals in the driver. So these must be variable resistance. You cannot put variable capacitance back here at those two sections. You put variable capacitance back here, you're going to have serious problems with your radio. So don't ever do that. Adam Williams, good morning. How are you? You got it, World Radio. That's right. Yeah. Thank you, Adam Williams. Appreciate that. Like, share, subscribe, everybody. Hit the likes or the thumbs up button.
Did you see Randall's thing?
Yeah, he said tomorrow. Hello, Steve. How are you? So now you guys understand all of that. So it's pretty much what I wanted to go over was the component recognition is understanding and identifying the problem, or the component rather, not problem, component, and also understanding symbols. So if you don't know what you're looking for or looking at, but you're just watching right along YouTube because you're trying to, overnight express your brain to do certain things, well, it's not going to work. Okay, you can't watch YouTube and say, oh yeah, here's what it is, and I know why. You can't do that. So, she's ready. Yeah. This is a great hot topic because I really didn't have one till I saw all the emails flooded in today. Early this morning, I got up to have breakfast. Like, what the hell is all this nonsense? I said, what do you mean? Someone's actually pulling out a trimmer or calling a resistor a trimmer? I said, oh my God, this is bad. So it's not to bash anybody. It's just to point out, if you watch a video and you hear or see this guy talking about, yeah, I do this and I do this, and we're going to show you not to get fake watts and blah, 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 and yeah, this is almost like towards the adjacent, but not quite sure. Guys, if you see videos like this and they try to sound professional, like they know what they are doing, stay away, okay? They clearly don't fully understand what's happening. And if you can't identify a component, good morning, Jim, if you cannot identify a component and its characteristics, know what the functions in circuit is for, then stop. Just please stop. Because if you don't understand that in its own, you have no business being inside of a radio. If you don't know what a starter looks like and you're just going to grab something and try to put it where it belongs to understand that if you got the right one or not, the right value and physical size aspects and connection points, then stop what you're doing, because you're going to damage that component wherever you're about to install it, if it even fits at all or lines up, right? So, because you got the appendix and everything else that line up with those, right? So you got to be very careful, no different than on a radio. Understand a component. What is the component? What is the name of the component? What does the component look like in different shapes, values, and sizes? Okay, and for appearances. Now, what many values could you use with this? Now, what would that work in circuit? What would be the fundamental characteristics of this component in a circuit? What would be the symbol in a circuit, so I understand it and I can identify that through a schematic? Because in a schematic, you're not going to see a physical part and say, here's a variable resistor. Oh, and here's a transistor. You're not going to see those on a schematic. What you are going to see is clearly, come on, bend, thank you. What you are going to see are symbols. That's an IC chip symbol. This is your PLL. Right here is a tuning coil. Okay? Here's another tuning coil. This is actually a tuning coil / capacitance, because right here is your capacitor. That's your symbol for capacitor. Now if you look at this one, notice how it's just a coil. There's no capacitance. It's a 4-post coil. This is a 5-post, 1, 2, 3, 4, 5 with a center tap, but with capacitance. So you can adjust the inductance one side, and you can also adjust the capacitance mixed with the inductor. So this is a variable tuning to obtain a frequency. That is your capacitor. Okay, they put a fixed capacitor in here with this to give it that tuning capability to change the value of the capacitance. Here's your diode. Okay, here's resistor symbol. Let's see if we can find you right there. Oh, right here is a transistor symbol. Okay, another coil. And right here, what is that, guys? It says VR204 delta tune. That is a variable resistor. Okay, variable resistor. So you have to understand how to ID the symbol, to ID the part, to ID the functions and features, and be able to trace this where everything's going. Like this here's a diode. I'm pretty sure that guy probably doesn't even know the difference, which side is anode and cathode. Your banded end, let's educate him. Your banded end is your cathode. Your unbanded, the backside of the diode, is always the anode. Okay? So these are just things to identify what they are. Right here is your crystal. It's not a capacitor, because right here's capacitor. People think, well, that looks like a capacitor. It's the same thing. I see the lines. It's not. This one is slightly curved with a straight line. Now, if there's a plus mark, then that would be electrolytic. This is a ceramic capacitor, a 6 picofarad capacitor. This is a crystal. 2 thick lines and a circle in the middle, like an oval. That is a crystal symbol. Okay? And then you got your transistor symbol. Now, the arrow points away here, which is NPN. Okay? If the arrow was pointed in, then that would be reversed. It's a PNP. That would stand for 2SA, 2SB. If it's NPN, which this is, which would reference to a 2SC or a 2SD. So you have to understand. See, 2SC, 1675. The L doesn't mean nothing at the end. That's just manufacturing information. But the 2SC, and then your numbers, that is the key factor of what this component is for your reference oscillator. That is a general purpose switching transistor. Is a 2SC 1675. 2SC 945 would work just the same. They share the same exact characteristics. The HFE on these might be slightly different, but you could put a 945 in place of a 1675 and make this function just the same and obtain the same voltages and the same functions and the same aspects of what this is supposed to be doing in a circuit with either of the two transistors. You cannot put a 2SA or a 2SB as in boy. That would be the opposite. It would not function because that becomes a PNP. NPN is where it points away for the emitter. That's your base, this is your collector. Understand the symbol, understand what the leads and what the characteristics of your pinout is, understand the value and what it can do, what it's not doing, why is it in the circuit, what does it switch, what are the functions. Same thing with the resistor. Why did they put a resistor here, this, that, and the other. So you have to understand all of this information. If you don't understand any of that information and you can't read any of this, then how are you going to identify what's in a radio? How are you going to trace a problem? You can't. Okay? So here we are. We have our, just randomly using a Cobra 29 schematic at the moment. Okay? You got your back jack here for DC voltage going in with a fuse. Here's your panel. This is the outside of the radio as the power plug. This is your actual socket on the back of the radio. And it comes on into a capacitor, to a choke, to a diode for protection. If anything goes wrong, you reverse the polarity, it shorts this diode out. That's the purpose of this guy. So I'm already telling you what the circuit's doing just by looking at it. And then you've got an electrolytic capacitor here to help filter that out. Here's a ceramic capacitor. Here's your transformer. Okay, that's a hash transformer. Then you've got yourself another ceramic capacitor. You got a switch. And then over here you've got yourself another ceramic capacitor. And you've got yourself electrolytic to help filter that all out, which is why they use a bigger value, and then becomes now your 13 volt source. As you go down the line, this is what you have when you close the switch. Okay, it makes continuity all the way across. Now you got your voltage. Everybody understand all this, how it works? Okay, if you don't understand, then you don't belong inside of a radio. Now, there's different formalities of diodes, for example. So like right here, for example, what is that? That's a diode. Well, why does he look different than this diode? Take and go look at it. It's a flat line. Well, this has kind of a letter Z. Do you know what that means? Z. What is Z for? Zener. Morning, Chad. How are you? So, Zener diode is this, which means this diode must be a functioning set voltage diode. So when there's voltage going across this circuit, this diode's put in there to say, hey, I need you to maintain this voltage, no exceptions, or this voltage is not going to work. This circuit's not going to work. Okay, that's the whole purpose of having a Zener diode here. If this was not here, that would not be 8 volts. It'd be high. The 13 volts would switch down through. This diode controls with a nice filter cap as well, electrolytic. That's the polarized. This is non-polarized ceramic. This is polarized, okay? That's electrolytic. This here would be to give you your 8 volts. That's going to hold the 8 volts when this switches. Otherwise, you got 13 volts passing through, which means this voltage regulator is not going to function correctly. Now, I also want to bring this to an attention. That says 2SC1096. Huh. Wait a minute now. That's a voltage regulator? Interesting, right? Because they also use 2 of those, what they call a push-pull circuit. You can use it as a voltage regulator, or you can use it as a push-pull circuit. What does that mean? It means you take 2 of those, you put them in circuit together, and now you have yourself an audio amplified circuit. What we know as an audio amplifier chip, like a TA7222 or a 7205 or a TDA 2003, the newer radios, they got the audio chips and those, a 5-pin lead versus 10, right? Well, instead of using an actual chip, an IC chip, they use 2 of these 1096s as a push-pull circuit to amplify as an audio circuit. So this 2SC1096 is used for multiple applications. So when you see this, like, oh, that's just a regulator. We can't use them for nothing else, just a regulator. That's false information, okay? So again, I see a 2SC1096 being used as a voltage regulator. Yes, I can. I can use one of those as such. But if I put two of those in circuit and change out my componentry within the circuit, now I can use those as a push-pull circuit to get an audio circuit. I can make an audio circuit out of those. So I can use this thing for two different applications based on how you form a circuitry within and around these components. Okay. Same thing with a 2SC 1419. Can be used either as a regulator, voltage regulator, or as an AM regulator, which is used also as a voltage regulator. So you can use it just for voltage itself, or you can use it as an AM voltage regulator to switch it on or not to 8 volts. So you can use that for multiple purposes as well. So understand component recognition, guys. Okay. Now another Zener diode down here. There's another switching transistor. Uh-oh, that says 2SA, not 2SC. Wait a minute. I thought only 2SCs did this. No, you can use a 2SA and do the same application. You can take a 2SA component, a transistor, and also use that as a switch or as a regulator or as an audio amplified circuit, provided how you have that in circuit and what you're trying to use it for. So these have many applications. You guys understand where I'm going with this? In other words, don't just look at it and say, okay, that's a transistor. Yep, okay, but it's bad. Well, how do you know? Well, I pulled it out. I saw it on YouTube. I tested it and it said bad. Okay, why did it go bad? Oh, I don't know, but it's bad. I'm a good tech. It's just bad. Just trust me. That's not a good tech. Okay, so understand, why did that fail? What circuit is it in? What is the applications of this component? What is the value and the function of this component? That would tell me exactly why it failed. Then I could tell you as a customer, hey, you overdrove the circuit, or it got hit by this, or the voltage was high, something fed back through and caused this to lock up, or that switch failed inside internally, it wasn't doing this, that, and the other. I could tell you all kinds of things, reasons why it had failed, if I understood in that circuit what was going on with this component. Okay, so it's very important. You must understand, what is this component symbol? Well, that's a transistor. Okay, but what kind of transistor? Well, this would become a PNP because the arrow is pointed in for the emitter, not out. Okay, it's pointed in, so the flow of your electrons are going through this way, opposed to NPN, the flow of the electrons will flow out. Okay, so now we understand the symbol. We know what that is. We can identify it. We can understand what its characteristics are all about, and we can see what it's in circuit for. Why are they using this at TR24? Well, they are using this as a voltage regulator, which controls a switch on their CBPA switch. That switches things back around. Okay, so now you guys understand that. You understand what this little Z looks like on a diode, opposed to a regular diode symbol. That is just a regular diode. This is a protective diode, which generally will be like a 1N 4003 or 4006, 4007 series. It would be a black diode with a silver band, would be this one. These here are glass diodes, whether it be red with a black band, it could be orange with a blue band, it could be clear with two different bands, whatever you want to do depending on what they are. In this case though, it's a Zener diode. It's not a regular diode. So this here would be a Zener diode, which typically Zeners are mostly orange with a black band, or I have seen some orange with blue band. But typically they're all orange with a black band. And they got different values in which they are. It could be a 7.2, could be this, could be that. Let's take, for example, because you got D22, you got D19, right? So let's go to D22. That's a Zener. Well, what is D22? How do we know what the voltage is? If we know it's a Zener diode, well, how do we know what the voltage is? Okay, well, let's find out. Then we can tell if that circuit's working all right. Okay, so let's say there's something wrong, for example, here, and we're not getting our voltage. That doesn't mean the transistor is bad. It could be the diode short in the ground. So let's go to D22 and find out what exactly is that value. Oh, let's see. gotta have that here somewhere. Semiconductors, capacitors, miscellaneous, microphone. Yep. We gotta find it. There we go. Got more parts list right here. D22. That is going to be D22 GEZD. ZD is for Zener diode. GE is for general purpose. Okay, it's a GE Zener diode, and it says 9.1. So it's a 9.1 Zener diode. So it's going to need a 9.1 diode in there in order to get this transistor to do what it's supposed to do. Where the hell did you go? Yeah. Right there. In order to get that voltage to drop to 8 volts. So this has to be a 9.1 volt Zener diode here to make that switch down through, and with the resistor and the cap load, it's going to drop this down to 8.4. So if you don't have this diode in circuit, that voltage is going to be high. It's going to switch, it's going to carry this 13 volts, this 12.87 volts down through. Now, if that were shorted, you wouldn't have any voltage at all. Okay? If it's open, this would be a high voltage. So if that's a high voltage, don't think that, oh, geez, transistors usually go first. That's not always the case. Okay? It could be this diode shorting the ground, or it could be open. If it's not shorted, it could be open circuit. If it's open, the voltage goes high. If it's shorted, the voltage goes low. And that would be the reference that a Zener diode would be the cause of pulling this transistor down, which means you just replace him only, check it, and your voltage should come back, and the radio should function. If it does not, then both of them may have failed. But 9 times out of 10 would be, in this case, just the Zener diode. This one's not compromised. It just switches it off. It can't do nothing until this one tells it what to do. Okay? So now you guys know why it's important to have Sam's photo facts, schematics, all the service manuals. You have to first identify the part. What is the part? What is the symbol? How do I trace it? What's the characteristics? What's the fundamental use of this component in a circuit? What is it supposed to do? What does it do if it fails, if it's open, or if it's shorted? These are the things you have to learn and ask yourself, because if you don't know this stuff and you're pulling out a part, well, it's a trimmer, but it's really a variable resistor, you should not be inside the radio. And a lot of these guys, like New Hampshire and Georgia, and there's one in Alabama, it's just sad. I'm not going to mention names. You guys, I'm sure you already know by now. We've mentioned them several times in the past before. And so, but they pretty much humiliate themselves, and it's very embarrassing to watch when they actually scam people and they lie to people. And the solder joint of which he had found that was fractured, I laugh because that solder joint that he touched up had nothing to do with the transmit or the receive section whatsoever. That was way the hell back in the corner by your filters. Okay? It's got nothing to do with the transmit and receive. Your transmit and receive, what controls it to operate, would be your PLL circuit. So if you lose transmit and receive both, you need to go to the PLL and the VCO area to find out what's failing there. Is the PLL locked or out of lock? Is it a bad solder joint somewhere? Or is it a bad crystal somewhere? Or a bad mixer somewhere? A bad VCO out of adjustment? Maybe it's out of alignment. That's where you go, is right to the PLL. You do not go to a whole different area of the board and say, yep, I touched the solder joint, now the radio's working. No. That could have been a voltage feed, it could have been this, could have been that, but where he was at was it was a filter cap. When you touch up the filter cap, it's back in the DC section. It's got nothing to do with the damn transmit receive. That's all in the power supply section of the radio. So what he probably did was put pressure on the board to see if that fixed one area, and by putting pressure on the board, probably found out he had multiple solder joints in a different area, which led down towards the PLL. As he started touching things up, then everything seemed to come back. But that's not the case when he did this, because I know later in the video he did say that he had to go through, touch up a lot of the solder joints around the front end of the board. Why would you say the front end of the board? Identify the board. What section of the board did you just clean up the soldering with? That would be the PLL, okay, or VCO or mixer area, wherever. Should be in that vicinity of your issue if it's cutting out both, okay? Unless you're losing a main source rail somewhere, which would be strange because you'd have to have a source fail. And if that case happens, you're going to have a lot more issues. So in most cases, it's going to be a bad solder joint or something failed, lock or out of lock of a PLL. Okay, so now you guys understand. I just gave you a whole wealth of knowledge for free from a professional trained technician. True, honest technician, myself. If you guys don't understand any of this, then don't get inside of a radio. If you need help, I will gladly help you. Call me. Email me. dxradioshop@yahoo.com. I will gladly help you, okay? But and I don't charge to help, guys. But please understand, if you don't know what you're looking for, don't touch the radio, because you're going to cause more problems than what you have in front of you. So, and that's what it came down to. Now, as far as Connex radios go, they're known for bad solder joint failure. However, they're also known for faulty regulators because of the current being set so high with the bias. You can't do that. You got to set the bias in the correct fashion. If you don't set the bias correctly, you're going to feedback burn out the regulator, you're going to burn out the finals, and then you're going to dump more money to a radio. Now, this is a 2950DX, is what we're using for an example, only for identifications, okay? So, again, this is your variable resistors in the back. Now, I want to point out also, why was this one junked? Well, here's the reason why. Let me shed a little light back in there. You guys see that? You guys see this? It's melted. That final was shorted out because the bias was cranked too high. Only one reason. Now, how do you know that? Well, I know because the bias is cranked so high. Now, that's only one reason why it failed. It would have failed regardless. But the other reason is because, look at this down here, guys. What the hell is this? Look at that. Look at this diode. Look how long these leads are on this diode. Okay? They got a switching diode, which is a 1N4148. I can tell if I can look at the body of this, and I can see actually part of the numbers. But I'm very familiar with these diodes. But they got this going right here, which feeds back through to your AM regulator stage. It's one of these little NPC deals they put in. So this is shorted, causing pressure back here with a high current bias set, shorted him out. Okay? So that's the reason why this radio failed. Along with other reasons too, that it just became a problem with the front end. He had a display issue, he had multiple problems with this radio. But the original problem was it quit transmitting, and that was the reason why. So now you guys understand, what you've got here in front of you. So as everybody, understands sections of a radio, let's discuss that very quickly too. Sections of a radio, very important. Okay. This is all your transmit receive frequency adjustments. This is all part of the VCO mixing, the PLL circuits. All of this right here is part of that. So this is all this section. And it says right here, RX, receive section, TX, transmit section. Okay, all transmit. What's this little guy here on the board, guys? What is that? Anybody can identify this? Put your comments down below if you can identify this. Make your comment what you think that is. It's an IC chip, but what do you think it is? What is it for? What part of the circuit is this for? That is your AGC circuit, guys. This controls your receiver, your squelch. It's a dual op amplifier chip. Oh, wait a minute. Stu just said dual op a dual op amplifier chip. How did he know that? Well, one, understanding the component, identifying the component, the characteristics of the component, and I learned component recognition many, many, many moons ago. So this is a circuit for AGC. That is a dual op amplifier chip, which is for AGC. Also controls your noise blanker. Also controls the squelch as well. This all ties into here. It does multiple things. That's why it's a dual op amp amplifier. Okay. So this here is all part of your AGC circuit. Here's your adjustments for your reference to do your S9 readings. Here's your audio, your carrier, ALC, transmit adjustment readings. Here's your 3 shorting tabs to put your board back in for your RF to pass through. When you set your bias, you would set those to the test points. Here's your audio strip. Here's your mic amplifier strip. Okay? So, I mean, I'm giving you guys very valuable information. I'm trying to teach you guys something very important so you don't damage radios. Okay? Most people will not show you this. Whether they just choose not to, okay, that's whatever, your choice. Or they just don't know. They just find a problem and find, okay, whatever. For example, I know of a guy, well, let's refer back to New Hampshire because he was actually the one who did it. So, anyways, he had replaced 7 capacitors only to find out that the last one he pulled fixed the problem. But then he lied to the customer, yeah, all 7 were bad. But he never tested them to verify if they were bad. Just the last one. And the only reason why he did the last one, he did one at a time. And when he got to the last one, it fixed the problem. The problem he had was no receive audio. Okay, so that would have been your output capacitor to your audio chip. What is he talking about? Well, let's discuss this. Give me one moment. I gotta take care of something. All right, here, start the truck for a minute. My daughter's got to go to school here shortly. Okay, let's go back to our schematic. Again, we're going to use a 29 for just for an example. Okay. So here is your circuit. Morning, bootlegger. How are you? Okay, that's your audio chip right here, guys. TA7222P. This is your audio chip. AF, audio frequency, power amp. Okay, so that's your audio power amplifier. Okay, this is your chip. Here's your input. Audio comes down through is your input. Here's your output. Okay, well, the output has capacitor right here. Ties back in. Okay. And you got one right here that feeds back through out to your audio output transformer. These 2 capacitors, one of which, or maybe both, could be the issue. He pulled 7 capacitors. The last one he pulled, again, we're using this schematic. He had a different scenario, different board, different schematic, but it's all the same fundamental. He would have gone to the output of the chip. That's where he should have gone to find out if the cap was in fact bad. If it is, it stops. You'll have modulation go through, but you won't have any receive audio coming back in because the caps are no good, one or both. That's what he should have looked at first. He did not. By the time he got to it, then he realized, oh, here it is. I found it. Yeah, it was a bad. He had 7 bad capacitors. Only to find out that the ones he took out were all previous, as he described, He says they were all ahead of the chip. Wait a minute now. That raises lots of questions. If you have bad capacitors ahead of the chip,
Ice honey, huh? Huh?
what?
I'm not talking to you.
Oh, we'll go. So if you have any capacitors that are prior to the chip, it's a problem because this is your modulation going in. This has got nothing, absolutely 100% nothing to do with receive audio. None of it. This is all contingent to your modulation going in. This is audio going in because this takes the audio, it samples this, it amplifies it, and whoop, there you go. We got loud modulation going on, okay? But this also controls the receiver audio as well. It's going to amplify that receiver audio. So it kind of comes back through, lifts back out. Either one or both of these caps would have been the problem. His case, he took out 6 capacitors prior and then 1 capacitor afterwards. That last capacitor afterward was the problem. These other ones had nothing to do with the circuit. Nothing. So he charged the customer for 6 capacitors that did not need to be touched at all, were not bad at all here, opposed to the problem was here. Again, understanding the circuit, understanding characteristics. Good morning, Corey. Understanding the fundamental of the component itself. If you don't understand any of that, you don't belong inside of a radio. If you want to learn, that's okay. Learn, ask questions, so when you do go inside of a radio, you are aware of what you're looking at. If you don't understand and don't want to understand, but you're just watching people just looking for the answer, oh yeah, he replaced, I don't know, C44. That was the problem. Okay, I'm going to write this down in my notes. Next time I see a problem, yep, it's C44. How do you know? Because I'm professional, man. I know this stuff, right? Then all of a sudden, the next time comes around, you find out, that didn't fix your problem. Yeah, your radio's junk. I can't, it's not worth fixing. Then they go to that excuse. Then they try to sell you a brand new radio. Or they try to take yours and trade towards it, or whatever you want to do, right? It's because they don't understand, because they don't know, because they realize, shoot, I screwed up, man. I thought that was C44. I really did. Man, how did this go wrong? What do I do? The customer's standing here waiting for me to make a decision. Well, I gotta do something. I can't tell them that I don't know what I'm doing. I don't want to lose business, right? And that's what these hack shops do. A lot of them do this. I've walked into many of them just to play as a normal person. I just want to walk in and, hey, what's up, blah, 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 blah. And I've actually taken, when they used to have one down at the petrol years ago, and they had one by the landfill. Hello, John, good morning. They had one down by the scrapyard. They had 3 different shops south of me over the years ago. And what I did was this. I would take a radio. I would unsolder a lead, pull it up off the board where it's just where it looks like the component is in there, but it's not touching. I'd lift it up just enough to where it wasn't touching the solder, and I would reflow the solder. And I would reflow the board around the surrounding area. So now you can't identify if the solder's been touched. That's what I would do. Now I take the radio down. Hey, this radio's not working. Can you figure it out? I wouldn't even tell them if it's not transmitting, it's not receiving. I did that later down the road. I would just walk in, hey, it's not working. Can you tell me why it's not working? And they put it on the bench. He'd look it over 10, 15 minutes, and I could tell he's looking at all kinds of places in the radio. It's like, you're not even looking at the right section. I know because I just, one, I'm the one who disconnected the component, and 2, me being a professional technician, I would have known what section it would have been anyways. Had he just did a preliminary check, turn it on, transmit. Okay, there's no transmit. I do have receive. Okay, what section should you be looking at then? Or I have transmit, no receive. What section should you be looking at? Or the radio does not do both. Well, what section should you be looking at? Or how about this? The radio power is on, but does not go into transmit mode. Okay, well, what section should you be looking at? Okay, so these are things you have to do as a preliminary check. Easy maintenance check on your radio when you put it on the bench. This guy had no clue. And I only went down to see what I was up against with this new shop that moved into the area this long ago. And they only lasted about 3 years before they finally got kicked out of the area for screwing people over. So what it came down to was this. He spent about 10-15 minutes. He looked at me and he says, yeah, there's a lot wrong with this radio. It's not worth fixing. But I got these brand new North Points. That's when those North Stars, North Points came out. I got these brand new North Points, early 2000. He says, if you want to trade this in, I can use it for parts, and I'll give you a discount towards a new radio. And I looked at him and I said, okay. I said, but you can't troubleshoot this? You can't find out? He goes, no, they don't even make schematics. The radio that I took down was a Cobra 29 LTD Classic. Well, geez, I have a schematic right here. So, and he went to cbtricks.com. That's when they all first came up with that too. So he's online looking, and he says, yeah, they don't make schematics for this. Like, huh, okay. So this guy claims he can't find a schematic, tells me it's going to be worth more, I mean, it's worth more for parts than it is to fix it. Okay, interesting. I wonder. So I told him, I kind of slipped up just a little bit, and I wondered, I said, well, what's the radio doing? And he says, well, right now, you've got nothing coming to your display. It's not turning on. So that's okay. But your light bulb comes on over the meters, okay. And so he says, well, I'm not sure what's going on with that, but it's just, there's a lot going on inside your radio here because I can't get it to do nothing. So what I did was I disconnected. The lead that I disconnected was a main voltage rail lead. I disconnected that portion of it. It shut the display off. Therefore, the radio does not know where to transmit or receive because it doesn't have any indication what to do, where to go. So by me shutting that down and reflow the solder, that's where I was at with the radio. That was the initial thing I did to the radio to test his knowledge. So he kept looking all around. I said, I don't know. He says, I can't. Your radio's completely garbage. I said, okay. I said, well, can you check to see if there's any kind of bad solder joint maybe or something? And he says, nah, it costs you too much money. I said, okay. But he really wanted that radio for parts. He really wanted me to trade it in for a small value and then go towards the North Point. He had the North Point 3000. And I said, nah, I'm not interested in one of those. They're ugly looking. I don't want one of those radios now. I said, nah, just put the covers back on. I'll take my radio home. He said, well, here, I'll give you $50 away. It sets for parts. I said, nah, I want to keep it. And we sat there probably like another 7 minutes, 8 minutes, going back and forth. All right, fine, I'll give you $60. I said, no, I'm going to keep my radio. So put the covers back on. I want to keep my radio. All right, fine. And then he handed it back to me. He says, you sure? $60. That's a lot for a junk radio. I says, no, that's okay. I'll take it back home. I'll keep it. He says, okay. I left. I came back down. 2 days later, I had a General Lee. I didn't even touch the General Lee. Customer sent me a General Lee. It did not transmit, but it did receive. I said, you know what? I already identified the problem. I knew what the problem was. The AM regulator was shorted out. I could see a pinhole right in between the 7 and the 5 where it said 2SB 754 on the AM regulator stage. What is he talking about? Well, let's say, let me pull this out here again, and let me show you. That is your AM regulator right back in here. Okay? And the General Lee had a 2SB 754. In between the 7 and the 5, you can see a blowhole, it's a pinhole. So I took that down. I knew what was wrong with it. And I took it down. I said, well, let me just test them again. Let me see what's going on. So I went back down. I like to have fun. So I went down and I said, hey, got this General Lee. Doesn't want to transmit. This time I told him what it was doing. Okay. Puts it on the bench, looks it over. He said, yeah, you got shorted finals, you got this, you got that. I said, all right. I said, what's it going to cost? He goes, oh, about, roughly, probably $150 to get fixed. I said, okay. What about labor? Like another $40 in labor. So we're looking at about $190 to get this radio fixed? I said, yeah. Wow. Okay. I said, how do you know that? You haven't tested anything, though. He goes, no, I know from experience. I know what's going on with this. Your filings are shot. It's going to cost a lot. I got to take the diodes in the back end. I got to replace those. I got to change out your resistors in the back end. Well, he called them trimmer pots. He's another one who calls these things trimmer pots. So I knew right at the get-go he didn't know what the hell he's doing. And I said, well, all right. I said, well, I'll tell you what. If you can troubleshoot it quickly and identify what it really is and then give me a better price of repair, I'd be interested. And he says, well, okay. So he starts looking around with a voltage probe. I said, well, where's your oscilloscope? Oh, we don't have one here yet. Okay. Well, all you have is a voltmeter and a dosimeter? That's it? He said, yeah. I could see his wattmeter. I didn't know if he had something else. He said, no, that's all we got. I said, well, what about a signal generator? Nope. Spectrum analyzer? Nope. Wow. So you're going to troubleshoot this and tell me what's wrong with it by using a voltmeter and a dosimeter? He said, yeah. But the dosimeter ain't going to do you no good because the reading's not transmitting. He goes, no. So you're going to just trace it down by voltage is what you're going to do? He said, yeah. Okay. Are you going to be able to tell that like through continuity as well if something's shorted? He said, no, I can just tell by voltage. Okay. All right, well, go ahead. I'll let you be. So he went down through, did this, that, and the other. He says, well, your voltages look good at the final. Okay. But they are shorted. Huh. I said, okay, if the voltages are good, they can't be shorted. Because if it were shorted, you wouldn't have any voltage. You'd pull the voltage down. Huh. That's strange. I said, okay. I said, what about the bias? Oh, no. We don't touch the bias on these things. They're all factory set. I said, okay, but are you sure? Did you check it to make sure it's at factory setting specifications? No, I don't need to check that. As long as the voltage is right there, I know we're good. I said, okay, but you said my finals were shorted, though. Yeah. But the voltage is good. Yeah. Then he proceeded to go to where the DC diodes were. And he says, by the way, that big diode off the back of your DC jack, says, yeah, that is what caused your finals to short. Oh, that's the reason why my finals shorted? He says, yeah. Man, that's pretty impressive how you identify this. He says, yeah. He says, I've been doing this for about 4 years now, 3.5, 4 years. I said, wow. Well, I'm pretty impressed. I said, well, let me kind of give you a little insight, if I could. He said, sure. I said, well, I came here, remember a couple of days ago? He said, yeah. It's okay. Well, let me tell you something. I brought my service manual with me. I pulled it out of my little briefcase I brought with me. And I said, hey, here's a book on the schematic you said you couldn't find. Oh, man, can I get a copy of that? I said, whoa, wait a minute, slow down. I said, let me ask you something. You told me you'd give me $60 for my radio because it wasn't fixable. It's only good for parts. He says, yeah, okay. But I'm going to tell you what I did to this radio, and I'm going to tell you what you should have done. And so by the end of that story with that, he understood more. He says, okay, then why'd you bring it here if you already knew that? Because now I'm going to tell you who I am. But before I do that, let me discuss about this General Lee for a moment. And I showed him how to properly look through the schematic. And I said I showed him how to use a continuity check and a diode check off his little multimeter to identify at least a short, if anything at all, and how to check the reference of that diode that he claimed caused the finals to fail, which was not the case at all. That diode is there for polarity only. So if you reverse your polarity, it shorts the diode out. That's all it's for. It's not for the finals. It's for the power coming in. So if you cross your hot and your ground, you're going to short the diode. It's supposed to blow to protect the rest of the radio from being damaged. It's got nothing to do with your finals. So I explained all this to him, and then I introduced myself to him. And we became friends for a while. He used to send a lot of radios down here for the ones he couldn't figure out. Finally, he bought an oscilloscope. He got one off of me. I had a good used one. I said, hey, you're going to need a scope, man. He said, why are you helping me when I'm only like 10 miles up the road? I said, yeah, okay, well, it's considered competition, but you're harmless, so I'm going to help you. I don't mind it. I mean, hell, so what? You're 10 miles up the road. You're not going to hurt my business on you. I've been here forever. So if you want to get a few customers, that's cool, whatever. I don't care. I'm not here to bash you. I'm not here to put you down. I'm not here to, kick you out of the area. You're either going to make it on your own or you're not. So I helped him out. I sold him a good analog scope, 100 megahertz scope. I sold him a bird meter. I sold him an RF sampler. I showed him how to build an RF sampler. Pretty cool guy. He was a really nice guy. His name was Randy. And then it got to the point where he couldn't take it no more because it was too much. He just wanted something basic to come in. If it didn't do this, he couldn't find it in about 15 minutes or less. Then he just, pretty much his goal was, I take it for parts, I trade it in, and I just focus more onto the retail sales of the shop. That's what he was doing. That's not the way to do business. He learned a lot from me. He was doing very well. Then he got back to the laziness. Then he got into some other stuff in his personal life that screwed him up, led to a divorce, and he ended up moving out of here to Michigan. And the kid who was with him, who took it over, his name was Chris, and he screwed a lot of stuff up. And then he got kicked out of the area because him and his woman decided to blow up an ICOM 746 Pro. They wired a power mic to it. They wired it the wrong way. There's voltage on one of the pins on that mic jack, so he shorted things out. Then they tried to do an upgrade. You can't do upgrades so much with those. You can only go to a certain point. He changed out a 2879 final in those damn things. He ended up putting a 454 final. You cannot do that. and they completely damaged the radio. That was only one out of several. And then Cobra 29s, he jacked up a lot of those, burnt traces, fried finals, swing kit galore, coil spreading, limiters pulled. I mean, it was a disaster. He had more people come back yell at him than they did go get things done, and that didn't last very long at all. So by the time Randy left, it was about 3 years, 3.5 years, I think overall they stayed. And by the time Randy had left the area due to his situation, Chris took it over, and he lasted like another maybe 6-7 months, and then that was the end of them. So, but the moral of the story is, guys, none of them understood component recognition. They did not understand symbols, didn't know how to troubleshoot, did not understand sections of a radio. They had no clue what they were doing. Such as the guy in New Hampshire who takes out 6 capacitors prior to the chip, only to find out his 7th capacitor was actually at the output of the chip. And that's why he had no receive audio, because he had a bad output capacitor shorting the ground, stopping the receive audio from coming back through. That was the problem. So had he understood all the basics of electronics and how to read a schematic, identify symbols, he would have realized, oh, well, let's go right here first and check and see if the output cap is a problem. And it's really easy to do. You can either check the cap while it's in circuit, or take it out and test it, or you can inject a signal and you can check to see if the tone comes through. If it does not, you got it at your input but it ain't coming out the output, well, disconnect the lead of the cap. If your tone comes back, you got a bad cap. If it does not come back and both caps test good, well, then it goes back to the chip. In this case, this chip does both receive audio and output audio. So there could be something internally failed to the chip if that's the case. But 99% of the time it would be an output capacitor. Okay, guys, so I think I've given you guys one hell of a damn history on my wealth of knowledge. And if anybody wants to call BS, then take yourself off a different channel, go somewhere else, and hang with the hacks. Because when you're here on my channel, you're going to learn factual information. Nothing here is BS. So you must understand what I just taught you is completely 100% just right there. Engineers designed the books, guys. Okay? And the guy who taught me, and I went to school for this, I mean, I worked for $1 billion company. I was in the end, I am not, let me rephrase that right now for everybody, so I want to elaborate on this. I am not an engineer. However, I was in the engineer department. I was hired in the engineer department, helping them troubleshoot, analyze, and improve many different things of what they had going on with these circuit boards and the failure parts of the board, what was most common failure. I also helped them in the machine section as to what was going on with a probe machine. What that does is had several probes touching the back of a board, shorting grounds, checking for, or well, not shorting them, but checking for shorts on the ground. And what was happening is when they did this, the pin, every time it jabbed, it would dull in the pin to the point where it had that little bit of space, just enough to where when it came in certain areas, it wasn't touching the solder joints. So they had 15 boards sitting off to the side. And I walked over, it's like, huh, what's wrong with these boards? I got to take them over to engineer. They said, yeah. Well, what's wrong with them? They all failed. What? What do they all fail for? Yeah, this resistor on the board here is a common failure. I said, what? That's okay. And this kid, all he does is push buttons. That kid was only hired to push the button, put the board in the machine, push the button, let it do its job. It either passed or it's failed. If it passed, it goes down the assembly line to the next phase. If it failed, it goes into a tray on a shelf, and then it goes over to the engineer, and they troubleshoot, and then they pass it back through for retest, etc. And I'm like, okay. I said, well, let me ask you something. That resistor is a 10K ohm. He goes, oh, I don't know. All I know is it's coming up and says bad resistor, and it points to the area. Okay. That's where it stopped in the program. He says, yeah. Okay, let me see your program. So I read the program on the screen. I said, okay, well, that's 10K ohm. He says, yeah. Okay. Well, you said you didn't know. Well, okay, so it says right in the program. Well, that's 10K ohm. I'm telling you what it is. He said, okay. Well, that's the problem. But it's a resistor. Yeah. He says, so why do you keep asking me about it? Because a resistor is like the least significant failure of a component. I said, so why would that resistor cause all this problem? You mean to tell me the company's got a bad batch of resistors? and all these are way out of tolerance, and that's what's causing us to fail? He says, very well could be. No, I'm not buying it. No. There's something wrong. So I went through, did an ohms check. Every one of those resistors were 100% right there within spec. It was not the resistor, just as I figured it was not going to be. And I got looking at the machine. And I said, I'm going to shut your machine down for a moment. He said, you can't do that. You're not maintenance. You just sit there and be quiet for a moment. It's lunch break anyway. You go to lunch break, and when you come back, we'll figure this all out. I'll get one of the engineers over here. So I sat down, looked at it. I had an engineer over there with me, so I didn't get in trouble because I'm not maintenance crew. I'm just there for technician aspect of things. So I had the maintenance come over, or the engineer come over with me, and we're going through all this stuff. He said, why would he say that? I said, I don't know. He said that it failed at the same damn spot of the program. So I'm looking at this. We did a trial run, and I'm looking at that, and I said, oh, wait a minute. I said, look at this. Your solder landing. Here's what happened. The solder landing, let me get this. I'm going to try to elaborate on this here a little bit. So here's a landing, okay? Here's your circuit board. The solder landing was be like this versus the next one beside it was like this. So what was happening was we had two issues. One, the solder landing like this, and when it hit over towards where the 10K was, those were actually equivalent. That's okay. It wasn't touching it because the pin kept hitting so hard that it dulled the tip. It broke the tip off. So by doing that, when it came down, it wasn't hitting. It stopped right there. And I caught that, and I could see it in midair. It's like, whoa. Look at this. It didn't touch. He says, really? Yeah, hit reset. Run that thing again. So we did, and sure enough, it's not touching. I said, no. Now, put it in the program where you want to put a stop. When it comes to that program, put a stop into it. You know how to program this. You're an engineer. Yeah, okay. He said, man, how did you know all this? Because I did machining for 9 years. So I said, I understand how this works. So I said, what you need to do is put in the program that you want to put a stop as it approaches to here, and when it completes its touch off, it stops before it's going to retract. He did that, and we found it was not touching. We could take a piece of paper and push it right back through. The thickness of a piece of paper is about 3/1000ths of an inch. Okay, so we took and put that piece of paper right on through. I said, look at this. It's not even touching. So I says, now back this thing off, check the tip of that damn thing and see what's happening. He pulled it out, says the tip's broken. I said, there's your problem. Replace the tip, ran it back through, boom. All 15 bores were perfectly fine. He says, wow, that's pretty impressive. You should be an engineer. I says, you're right, but that's okay. I don't want to go to college for it. I don't want all the additional stuff and all the expenses I got to go through. I'm happy right where I'm at. So if I can learn all the material like an engineer, I'm happy. I don't need to be licensed or certified or recognized as an engineer. That's just more knowledge for me I've learned along the way. And I just take that and put it right under my belt with more things I learned. That's the human life, guys. It's your cycle of life. Learn as much as you can. You have a brain. Let that thing be a sponge and soak up what you can. Whether you use it once, twice, or never again, at least you learn something new. And I knew from my machine shop experience, programming, how to read the program, where to put stops to see if there's an issue, and how to remove that in the program as well, how to write it, read it, and remove it. So I did all that. I went down at Gold's Pump, which is another multi-billion-dollar company. I did that for a while. So by doing this, I understood. I said, no, this is wrong. So when the kid came back, he said, you guys figured it out? Sure did. All these boards are good. Pass them through. He said, what do you mean? And I showed him what was happening. I said, you need to pay attention to that tip. You weren't watching this. You're supposed to replace the tip every 55 to 60 boards that come through. You need to check the tolerance of that tip. And it said it right there in his procedure book, which we later found the engineer showed me. It said 55 to 60 times check that tip. He never did. That was the cause of it. So there you go, guys. I'm not an engineer, but I tell you what, I think like an engineer. I have engineered many things of my own, but I got so much wealth of knowledge you're going to find here. You're not going to find, at hack shops. So again, let's go back to our basics, what we discussed about. Component recognition. That means identifying a part, understanding the part, the characteristics of the part, the fundamental use of the part. What is it meant for in the circuit? How do you identify if that part is a cause or an effect of any kind of issue within a radio? You have to understand all of that, the symbol of the part, in order to trace it out on a schematic. If you can do all of that, which is all listed under component recognition, that identifies everything. If you can understand all of that, then yes, proceed. Take the covers off and do your troubleshooting. If you cannot, and you call a potentiometer a trimmer, something is completely wrong. You don't belong inside that radio. You need to take a step back. You need to read. You need to understand a few things, kind of go from there. So I hope everybody understands everything I just explained to you, and I hope that's a good wealth of knowledge shared, which I know it is, but hopefully you guys understand this as well. And so put your comments down below. If you have any questions, put them down below. I'll gladly ask you. Or you can email me, dxradiosshop@yahoo.com, or you can call me, 315-945-1600 is my cell number, and I'll gladly help you. I've got people from Wyoming, Iowa, Arkansas, Kansas, Ohio, Nevada, San Jose, California, all the way down there to Mesa, Arizona. I mean, we've got people from all over the place that constantly call me and ask questions because they want to learn the right way. And I'm not going to mention names, but I will say they are doing an excellent job learning, and I appreciate that, and I look forward to helping them much more, because I think they are doing the right thing. They're going the right track. They're really wanting to learn, especially the guy in Wyoming calls me all the time asking questions, and I love it because he's asking questions. He's understanding that, and if he's not sure, he's going to ask me again. Well, okay, can you explain this a little bit more? Absolutely. And I like that because he's really learning. So I'm going to say Mr. Wyoming, because I'm not going to put his name out, but the guy in Mr. Wyoming, you know who you are. Keep up the good work. I'm proud of you. You're doing a great job. Keep up the good work. Don't give up. You're doing great. So, and everybody else in the other states as well, you guys are also doing great. So, if anybody got any questions, like I said, don't hesitate. Ask. If you don't ask, you're not going to know. If you don't know, keep your fingers out of radios, because that's when things go bad. So, but again, like, share, subscribe, hit that thumbs up, guys, and I hope that I gave everybody a lot of good information to go by, and the ones who are learning, hopefully we also showed you in the schematic how to troubleshoot a little bit more to identify the problem, instead of just pulling out 50 parts and find out the last part's your fix. That's not troubleshooting. That's a part swapper. Okay. And the guy in New Hampshire pulled out 7 capacitors before he realized the 7th capacitor was the problem. The first 6 had nothing to do with the circuit at all. He was not even in the right area of what was going on with that radio with the problems. Had no receive audio, which has got nothing to do pre-amplifier stage. It's after the amplifier stage, which is where it comes in from your external speaker jack and your PA, comes right back through to the audio output capacitors, and that's where the problem was the capacitor. So that's what he should have done to troubleshoot it better. Hello, Steve. How are you? Matt says, so a bad output cap from the chip is a common issue for no receive audio on Cobras. That is a common failure, yes, but try not to say that as common failure. Because, and I don't really want to say it's a common failure. It is, but it's not. In other words, don't justify that as until, okay, no receive audio, it's got to be the cap. 9 times out of 10, it usually is, especially on the Cobras and whatnot. But please keep in mind, it could also be the chip. It can also be a shorted external speaker jack. So, or it could be a cold solder joint. So it could be multiple things related to it, but there's not a whole lot in the circuit to look at when it comes to the receiver audio section, because you only have just a little bit, a handful of parts. So you can narrow that down pretty quickly for sure. But if you have modulation going out, in this case here with the 7222 chip, if you have modulation going out and you got no receive audio coming in, check the output capacitor. If that is good, then you got to look to find, okay, is it internal to the chip, or is your external speaker jack not open and closing all the way? It could be oxidized, it could be, whatever, beta solder. So I've seen all kinds of different natures of that. But it could be a bad external speaker jack, and the way you do that is take a screwdriver and you touch the 2 tabs. If it comes back, you got receive audio, then you got a bad jack. If it don't, then it can either be it could be the chip itself, something internal had failed, or it could be the output cap. So, provided what the nature of what you find, but yeah, that's about where you'd want to start though. If you had no receive audio, check it. Now let's eliminate, because you know we're going to have trolls say, "Oh my God, he didn't mention about the microphone." Blah blah blah. So let's assume that you've already checked your microphone. You checked the receive pin. There's no broken wires on the receive pin. Blah 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 blah. So let's just assume that all of that from the front of the radio to the back is perfectly fine. Let's assume that the problem is, in fact, at the output of the audio chip. Okay, so if we can narrow that right down to there, most cases it's either going to be a cap, or it could be a shorted external speaker jack as well, or it could be internal to the chip. Now, the internal portion of the chip generally does not fail often at all. That's very rare. It could be due to poor manufacturing of the chip. It could be due to just a fluke age of the chip. Most cases, it's not going to be the chip. I'm not saying it wouldn't be, but the likeliness is going to be more so the capacitor would be your first suspect, or shorted external speaker jack, opposed to the chip. So I would look at those two components first to see if you're not getting connection from the external speaker jack, which we've seen many times here in the bench, or the output capacitor. And then I would trace it from that point and inject the signal and see where it comes back, where it don't come back. I mean, you can check your output cap by just injecting the signal, and you find out, hey, I got sound right now with that cap disconnected. Okay, as soon as you connect the cap, the sound goes away. Well, there you go, back cap. If the sound is not there when you disconnect the cap, then I would look at the oscilloscope and see the signal. Do you have amplification from pin 4 versus pin 9? If you do have amplification, but you just can't hear it, okay, well then I'm going to go look and find out about the external speaker jack. I wonder if it's shorting, if it's not making good contact or separating contact. So I want to look at the jack. And if I find out there is a problem, then okay, fine. So that's about where you want to be, though, is either the output cap or the external speaker jack, or last resort could possibly be internal failure to the audio chip, but that's not likeliness. That's like less than 1% of the time that you'll ever see an audio chip completely fail. Usually when they fail, it's because someone's messed around, or it's due to age, or it's due to the fact that they have all this slamming audio going into the radio, the audio chip, because they got limiters pulled and saturating every little thing you can imagine. It's only a 5.8 watt audio chip, so if you overdrive that audio circuit, eventually the audio chip becomes a weak link. But if that's not been hacked up and everything else, everything's working pretty well, then okay. So the likeliness of your audio chip failing is not usually the case. It does happen, but not usually the case. It's more or less going to be a cap, or the jack in the back, or a cold solder joint, or something along those lines. Yeah, it's a good start to look at, for sure, yeah. Okay, so you have, I'm assuming you got a Cobra, right? Was it like Cobra 29 of some sort? Is that what you're referring to? That's okay, so it works perfect, then the receive slowly fades out, and then nothing never comes back. Okay, so that would be probably due to other reasons. Check your soldering. Make sure you got good solder flow everywhere for bad solder joints. Press on the board, see if it comes back. I would look along those lines to see if you got any kind of bad solder joint or fracture. Or I would check for, well, I guess I'd start there first before I go anywhere else. 29 LTD? Okay, yeah. Yeah, so I would check to see if your receiver is strong, and then it fades away. Now, is this, when you turn it on, you got good receive, then it fades away? Is this all the time, or is this when it comes up and goes down, then that's it, right? You said so. I mean, can you get it to come back and then it fades away, or is it kind of just when you turn it on, it's up and then it fades away and then that's the end of it till you turn it back off and on? I mean, give me a little bit more descriptive information there, that I can kind of give you a little bit more to justify. But I would press on the board, look for cold solder joints with that. When you say the receive fades away, is it receive audio sound, or is it receive signal in audio sound? Because if your signal fades away, then that's a different portion of the circuit. If it's just the sound, your audio sound fades away, but you can see your meter and you got a strong signal coming in, but you're just hearing the sound itself. If the received audio fades away, but the signal's strong, then we got to go back and look for a capacitor, a cold side, or something along those lines. Something's draining it down. It could be a shorting diode failing. It could be something changing along those lines. I don't know. It could be several different things. But if the signal itself is also fading, then you got to go to a whole different area. You got to go back to the receive strip. You got to check your you got to check your crystals, make sure those are all functioning, mix and frequency is good. You want to make sure that at that point that it fades out, does the radio still transmit? So you have modulation going out. Can you hear that on the same channel on a nearby radio, on a monitor radio? If you transmit and you can still hear yourself loud and strong on the same channel, then we know that, okay, we got to go back to your receive strip. I'm just wondering if that fades away, does everything else fade away? So we got to separate your transmit now from your receiver stage. So if the receive is fading away on both signal, obviously, and your receive audio is going to go with it. So if you're losing signal as well, then we got to go back to your 455 kilohertz filter. We got to start looking from that point there. Or previously yet, we got to go back to your RF amplifier circuit and see what's going on, because that's supposed to amplify the signal coming through to the receive stages before it gets to the IF 1, 2, 3, 4, etc. So I would be looking more to that if you're actually losing the signal, or if you have strong signal but only losing the sound. Then we go back to the other direction, the output capacitor, find out if it's a cap, or it could be a cold solder joint. If you have signal but you're just losing the loudness, the sound itself, the audio portion of it, sounds like a capacitor is going. So, good question, very good question. But it gives you kind of an idea where you want to start from, not knowing what you have right now as far as, are you losing signal or are you just losing receive audio sound? If you're just losing receiver audio sound, I would be looking at your output capacitors, is what I would do. Okay, it did it once, fade out and never came back. When you turn it off, back on, I believe it's just the sound. If I remember correctly, the meter still showed incoming signal and still had transmit. Okay, so that is exactly what I just described. I just explained to you. Okay, so your radio is working outside of, it's just not getting the receiver audio. That part faded away. So I would check your external speaker jack to make sure that is functioning good, but I would go to your output capacitor. So your output capacitor we just showed you here would be it's going to be C45 and C48. Check those two capacitors, C45 and C48. All right, and those are a 47 and a 470 microfarad, which is going to be, let me see here. What technician goes out of their way to educate people and actually take the time to show you? Think about that. So for all you people that are running hack shots and really don't know and don't care, shame on you for screwing people over. Okay, it said 45 and 48, right? So we need to find out. Well, these ones are all blowing up down here. Jeez. Okay. So these two capacitors right here in the back, this is a Cobra 29 LTD. These two caps in the back. So you're gonna let me elaborate this here for you. There you go. Okay. So here's your DC power coming in. Okay, so this is the DC side component facing you. You got your hash transformer, your audio output transformer, and then right here is going to be your audio chip. And these two capacitors, C48 and C45, two electrolytics. I would check those. One of them are going to be bad, maybe both. But those two capacitors right here are going to be what you need. Okay? Thank you, Ed Williams. Appreciate that. And I really appreciate that as well, Matt. I'm glad that you are looking to learn the right way, because I don't want to see a damage your radio and give you the wrong information. So yeah, right here is going to be your capacitor. So when you take your cover off your radio, next time you get a chance to do that, follow your DC power coming in the same side wall. You're going to see your audio chip, and then right here are going to be the two capacitors, C48 and C45. Those two electrolytics. Okay. If you don't have another parts radio, or if you need the parts, let me know. I'll mail you the parts. I've got capacitors up the wazoo. Okay, so but that would be your output capacitors that you look for. They're right down here in this corner by this big transformer and your 29 LTD classic radio. Okay, so that's where your two output caps are going to be, right down through here. Check both of those capacitors and see if your sound comes back. It should at that point. If it don't, remember I was talking about shorting your external speaker jack? What you do, of course, this is all in the way, spaghetti wires. You're going to take the two terminals here. Let me see if I can. There we go. Yeah. Okay. Here's your terminal external speaker jack, way down here in the back corner. This top lip edge and that connection back there, touch those two with a screwdriver. Just touch them like this. Just touch them. Okay? And if this makes contact and you have sound, you got a bad jack. If it does not, then we go back down here to these capacitors right here. C48 and C45. Okay? That's where you're going to have your problem, because you do have signal, but you don't have sound. And you also want to check to make sure your volume control is not dirty as well. Because when they fade away, that could generally come down to like a bad potentiometer in the front end. And notice how I said potentiometer, because all of these controls right here, guys, are all potentiometers. All potentiometers. Okay? Also keep in mind too, Matt, check your split pins. Don't spread them apart too much, but check your split pins. You want to put just a little bit of space in between like this, because maybe you're not getting a good connection between the mic plug and the mic socket, and that could be draining out your receiver audio as well. Unless if you move your mic plug around, then that might be a variation as well. But just kind of spread the, split your pins a little bit to make sure that's not part of the issue. But in most cases, as long as you got signal and you got nothing else and everything else is pretty good, let's assume the jack in the back's good, the mic's good in the front, then it goes down to these two capacitors right here. Okay? Very good. All right, guys. Well, I think our education kind of overlapped in my timeline because it's already 8, and I got to get to work. I'm 15 minutes behind schedule. I got to get to work. I got some radios to fix. So, got 6 radios done yesterday. And let's see what we can do today. So today is going to be a HR 2600 radio. And we need to pull this chip off the board and transfer a different chip onto the board, which would be, this is a UC1251. We need the UC1250. So we're going to take this chip off the board, put the 1250 in place of this chip, and then this radio will have 10, 11 meters. Right now it does not. It's strictly just 10 meters. So we got to remove this chip switch, put the proper chip switch in to obtain that mod. This is a 64-pin programmable PLL chip. So this hole has to be taken care of. And then when we get all said and done, then we got to mount that back into the carriage. And then we get all said and done with that. That's the fun part. And then we gotta put that all back into here where our wire harness goes. Can you imagine? What CB shops have no clue how to do any of this. They're probably thinking, oh my god, which plug goes where? So, okay. That is going to be today's project. So that's what we got going on right now. This is, oh, Mike. This is your radio, buddy. So we're going to be working on that today and see what we can get accomplished with it. And then your HR 2510 as well. I believe you got, yeah, I think you got 2510 in the box here with us. So we're working on the 2600 first to get that all squared away, said and done. So, yep. Wow. All right, guys. Like, share, and subscribe. And if you got any questions, drop them down below. Feel free to ask anytime. The ones who don't ask are the ones who are never going to understand. So please, no wrong answer, no wrong question. Just we'll put you in the right direction where you need to be, okay? And if you guys have any, influences or interests into learning, and you want to further your skill set, call me. I'm not going to put you out here. Like I said, the guy in Wyoming, he's always. I mean, everybody they call me. I get phone calls all the damn time, or emails. But the guy in Wyoming, God, he calls me all the damn time, and I like that because he'll text me. Is he busy? If I'm not busy, I'll call him back. Yeah, what's up? And we'll sit there, we'll talk for a little bit, help him out, get him through the process, and he is doing exceptionally well on his learning. So I'm very pleased with that. He's retired, and he's doing a great job. So keep up the good work. Everybody else out there who's always calling me, keep up the good work. And Matt, let me know how you make out with your radio. If you need any more help, let me know. I'll get you in the direction you need to be. But that's about a starting point where you want to go. You should be able to identify and find the problem at that point. So let me know how you make out for sure. Anybody got any questions? Like I said, drop them down below. If anybody wants to know more about this, you can always Google the component recognition. It'll set you a guide, this, that, and the other is what you got to do. But the difference between a trimmer and a potentiometer, one is variable capacitance, one is variable resistance, and a trimmer cap is a variable component used to calibrate RF circuits. It's also used to calibrate as far as your frequency response to align any kind of frequency values for rise and fall times as well. Whereas a potentiometer is more for voltage divider. It's a variable resistor circuit. That's what a potentiometer is for, is to change the value of resistance, the voltage going across, such as light brightnesses. You can change a light bulb to be brighter as a strobe light, this, that, and the other, or for bias settings or what have you, to set the current for those to the driver to final, etc. But it's meant for measuring electric potential voltage. That's what potentiometer is for. Okay, so if you don't know the difference from a capacitor and a resistor, please look that up first, and then you'll understand more what you're going to get into. When you pull out a potentiometer from the bias circuit and you call it a trimmer, that's where you need to stop, back up, and start reading the right material, because someone's feeding you a lot of Kool-Aid you should not be drinking. Okay? And this person I tried teaching years ago, and I had to walk away because he's just completely illiterate. He just doesn't want to. He doesn't want to listen. And as you can see in this video, I can't tell you how much information I just gave you in the last, what, hour and 20 minutes, probably, hour and a half. I just gave you like a whole bunch of information for free. Okay, so please, guys, that's why we're here. This is why we do our videos live stream. No editing. We don't prep ourselves. We don't sit here with somebody in my ear telling me, Stu, just tell them this. Believe me, it's right. You know, this is stuff that I've learned for 39 plus years, guys. I've earned my spot where I am right now, where I belong. Okay, if people don't like it, well, don't be jealous and don't hate me. Learn, better yourself. We need more technicians, guys. So all you hacks, stop being jackasses. Start learning the right way, and progress in the right motion. Don't hack a person's radio up because, you know, little Johnny down the street says, "Hey man, spread those coils. Look at that. I got 4 more watts on my dosimeter." So next thing you're gonna know, somebody's gonna say, "Hey, take that 2166 drive route. Let's put a 6LF6 tube in place of it and see what happens." Yeah, now you go from a 12-volt system to a 600-volt tube, right? So, goodness gracious. All right, guys. Anyways, take care. Hey, Leadfoot, how are you? Richard from the UK was asking about you. He was saying hi and was wondering how you're doing. So, good to see you on. All right, guys, take care. Enjoy your Wednesday. I'll be back shortly here at the DH Radio Shack with this HR2600. I'm going to go through, replace that chip switch, get it all up and running, and then we'll go through the alignment procedure. At that point, we'll do the video on the alignment procedure, etc. So, but I'm not going to do the video on the chip switch because it's going to take some time to do that anyways, and I don't want to make it too long of a video. So, but anyways, we'll catch you guys shortly here, and stay tuned. We'll be back shortly. If you got any questions, drop them down below. And don't forget, we have several quizzes that we've posted on our community page for you on the YouTube channel here as well. So when you get on the video, check it out. Visit our community post and give it a whirl. Check out those quizzes. Test your ability. If you get it wrong, don't be upset. It's something you learn. Read it, learn it, and understand it. And if you're trying to get to the hobby, a lot of those questions, I had several questions I did myself that I came up with, but several of those questions, guys, are from the ham radio exam test. So if you guys keep watching those questions, I'm going to throw several in every now and again and mix them up. And if you guys watch those, then it will help you getting your ham license. Because when you go to study, you're going to say, wow, I saw that on Stu's channel, on his page. I'm getting the same information right from those sites, guys. I'm just taking the information they have, and I'm going to reword them. So it's not plagiarism. I'm rewording them, and then giving the answers, mixing them all up. So if you guys watch those quizzes, and you'll be able to study for your ham license. A lot of that information is coming off of the ham sites. So pay attention, okay? Because if you do want to go for a ham license, then check out the quizzes, check out their sites, and study. It's not hard to do. 35 questions. You can walk out as a technician class operator, go back in, restudy again. You can walk out with a general class. You can talk all over the world and have a blast. Okay, so on that note, I'll see you shortly here at the DH Radio Shop, guys. Everybody enjoy your Wednesday, and we'll be right back here shortly.